Right. In some of our last videos, we went over some of these weird coincidences, such as radius of the sun multiplied by the perimeter of the pyramid divided by 10 gives you the circumference of the Earth. And we've gone through a couple of these, actually. And another example, let's take the radius of the sun, just so happens to be the old tuning system for music, which is 432 hertz. And also the same frequency as Om, which is one of the most important sounds in Hinduism, is apparently the sound that created the whole entire universe and does have its associations with the sun. I'll show you actually towards the end actually how Om connects with the sun. But you know what? Why stop here? Because there's a lot more crazy coincidences involving the pyramid. And one of them is it also accurately predicts the radius of the Earth. Now, we take the radius of the sun in miles, multiply it by the height of the pyramid in meters, and there's evidence that the Egyptians actually did know the meter. So you take radius of the sun multiplied by meters, and then you take that answer divided by 10, you'll get the radius of the Earth, basically. So before I go any further and before we test this out, I think I should also mention that the Earth isn't a perfect circle. It's actually more of an oval. And the difference is very small. So if you look at an image of it, you're not going to notice. However, the radius from the equator is slightly larger than the radius from the center to the North Pole. And what we are using in this calculation is actually the radius, vertical radius from the North Pole to the center. Now, there's many reasons why the world is a bit of an oval. One of them is because the moon is going around the Earth, and just like the Earth's gravity is pulling in the moon, causing it to go around, the moon's gravity is pulling the Earth, and the moon is going around the equator. So the equator is bulging out, creating a slight oval shape. All right, so let's test if this is true, if I'm like, haven't made a mistake somewhere. Let's first check the radius of the sun and see if that is correct. And I've done it before. My search radius of the sun in miles, we have 432,690. And here in my presentation, I put 432,690. So we can tell that most definitely is correct. And with that being said, I'm going to put that number into the calculator and we are going to work this out. So 432,690. Okay, and then we're going to multiply this by the height of the Great Pyramids, as you can see here. Well, how high are the Great Pyramids? Here's a 3D model with all the proportions of the pyramids I did for a course that I teach on how to build 3D designs and stuff like that. And I reference a lot to the pyramids because there's a lot you can learn from it. But the number I work with for the height is 146.7. Let us go prove that that's true, that it is in fact 146.7. Now, before I go further and search this, I should also mention that the pyramids of today have been vandalized and slightly destroyed. Basically, the pyramids used to have a white limestone casing around it. The pyramids actually used to be white, and the tip point used to be made out of gold, right? Why doesn't it look like this way today? It's because different cultures throughout history stole from the Great Pyramids, took off the limestone casing and the gold at the top to build other monuments. This means that the pyramid actually used to be larger because it had more rocks around it. And today, we don't know the original height exactly of the pyramid, right? But we have a pretty close estimate based off all sorts of things, such as ancient writing and accounts, and also looking at the modern pyramid and making estimates as to, how large that limestone would have been. So you'll find that generally over the internet, they will say 146 point. However, they will be off maybe by a slight decimal. So some will say 146.6 was maybe the height of the pyramid. One will say 146.5, right? But generally it stays around that 0.5, 0.6, 0.7 estimate. And you can do this same calculation using the slightly different numbers. You still get within 99.95% accuracy the radius of the Earth. I would also like to add, you know, my 99.85% accuracy may even be 100% accurate because of the fact that we actually don't know the true height of the pyramid. You know, I don't know. Maybe, you know, if we knew the actual height, the calculation would have been within 100%. But that's just a guess. So let's go over here and let's type, let's go original height of the Great Pyramid. All right, put that in. All right, and nope, this is giving the height today, okay? But I'll go, okay, there we go, this is better. So this 139 meters, that's wrong, but you go how tall? It says here at 146.5, and mine is 146.7. So that's 0.2 decimals different to what I've put into the calculations. This other one, Wikipedia, will give you a different number, but still the same, initially standing at 146.6. So it's 0.1 larger than what Nova is saying, because Nova is saying 0.5, this is saying 0.6. So as you can see, we don't know 100%, but we know it was 146 point something, and it was most likely around 0.5, 0.6, 0.7. In my calculations, I will stick with the 146.7. So now we're going to throw that into the calculator. So here we've put the radius of the sun. Let's multiply it with the height of the Great Pyramid, 146.7. And then we're going to go, and we get this number, 63 million, right? But remember, we need to divide by 10. And I'm finding with all these like pyramid calculations, almost all of them seem to divide or multiply by 10 for some reason, right? I don't know what variable 10 is supposed to be, but it seems to be quite important. I take this number, let's divide it by 10, and let's see what pops out on the other side. We have 6 million. So we have 6,347,000. Okay, and then it goes 562. Look at the number of the radius of the Earth. It goes 635, and this one goes 634. What is the error? Well, this is actually 99.85% accurate. In other words, it's only off by 0.15%. Furthermore, because we don't know the exact original height of the pyramids, we don't know if this calculation might actually be 100% or not. Okay, but let us see if we can, let's prove that this is 99.85%. How would we do that? Well, we see, I take this answer I've given and I see how well does it fit into the radius of the Earth. Does it fit perfectly like a glove with no extra or no less? Or is there a little bit off where it kind of fits, but it's a little bit larger or it's a little bit smaller, right? And to do that, to find that answer out, I'm going to put it as a fraction. So I'm going to take my answer and I'm going to divide it and by the radius of the Earth. That R stands for radius. We take the answer divided by the radius of the Earth. Anything divided by itself is 1, right? So 5 divided by 5 is 1. If you get 100% of 100% of all the questions right in an exam, okay, and it was out of 100%, 100 divided by 100 is 1, right? So if we get a 1, we know we're right on point. But if it's like, right, if it's like 0.9999, it's close. So that's how we're going to do it, right? So here I've got the our answer, and I'm going to actually divide it by the radius of the Earth, which is 6,357. 1, 2, 3. Okay, that extra one over there. All right, and he's going to check everything does in fact look correct here. All right, I'm going to hit that. Okay, and it's almost 1. It is 0.998. How accurate is that in terms of a percentage? Well, for us to turn this fraction into a percentage, we're going to multiply by 100 because there is 100%. And we have a 99.85% accuracy. To get this to be 100, you need an extra 0.15%, right? Just tiny. So it's only off by 0.15%. You know, what are the statistical odds of that? But what is the reason behind this as well? Why would this be? It's my question. Now I have something else to show you before I end this presentation. I'm just going to press pause while I fetch it on the screen. All right, so continuing off. So remember we said the sun is 432,000 miles radius, and that is also the frequency of ohm. In fact, you go, what frequency is ohm? It is 432 hertz, and it was also what we used to tune all our old music to until they changed the standard to 440. Well, reading up a little bit more about ohm, this is on Wikipedia, it says the word ohm, and this is a quote from the Upanishads, which is a Vedic text. All right, it says the word is ohm, its light is sun, and the sun is also the light of the syllable ohm, asserts the Upanishad. So here we have the Upanishads linking ohm to the sun, and here we see the 432 being the radius of the sun. Also says here, light is the sun, which is the syllable of ohm itself. Very interesting. Now, you might have also heard, this other thing that I do want to point out. Actually, I'll save that other bit for another video in future because I see this one is getting quite long. So I think I'm going to close off here. But if you found this interesting and you want to find out more, be sure to check out some of the other videos that I will be posting. And I am also putting together a whole, so every Saturday, actually, I'm going to be doing a webinar, free webinar, where you can ask me questions and we can talk about all these sort of things because I like sharing it with people. I find it incredibly fascinating, and I also do enjoy learning things from other people. If you'd be interested in that, well, sign this form, and then also you can join the meeting, which is on this link. Now, I've also put together, you see, I teach online classes. I've put together a maths course that incorporates all this sort of stuff. You see, a lot of the people I teach go to school, and during exam periods, it can be quite stressful. So I decided I'll put together a maths course, but one that's fun and entertaining and kind of it consists of two elements. One, it turns maths into a game rather than just doing boring old maths. We kind of play something similar to Dungeons and Dragons, where they need to use their knowledge in maths to find their way out of the maze of the underworld. And I mix that in with, you see, a lot of the questions they do are similar to this sort of stuff, where rather than when they're doing exercises and learning this sort of stuff, rather than giving them just random numbers to calculate, every single calculation they do, like, shows them something profound about the universe, ancient architecture, or ancient mythology. Every single calculation means something. And as they start to, with every single exercise, a story starts to unravel. So if you're also interested in that, you can sign this form, get in contact with me, and find out some more information about that course. It's basically a very fun and entertaining way to learn maths. And, you know, even though it's mainly aimed at kids, if you're also interested in learning about, you know, mythology and how it links up with mathematics and how the ancients used to approach maths, well, I can also show that to you. All right, cool. So I'm going to end this video here, and I'll see you next time.